Uh,
How did the day go?
tomorrow,
Say it again.
tomorrow's my birthday.
Oh, what? Tomorrow's what, Thursday? Wow.
Yeah,
You coming to class?
yeah. I celebrating it on Saturday, so yeah, I come to
Oh,
class.
okay, celebrating on a Saturday. Okay, all right, wow. So you giving us a virtual birthday cake? How are we gonna split this? Oh wow.
I I guess.
Oh wow. Wow, that's so nice. April baby. It's too bad you wasn't born in February. But April is close, so I guess that's good. But
I born the same day as the Queen. I figured that out last year.
okay. Royalty,
The Queen.
royalty. That's amazing, man. Thank God for another year. That's amazing.
Yes, sir.
All right, so this is day 3, week 15, right? Some people already had a 2-day vacation from class, but we actually had class on Monday and on Tuesday, right? So this is our 3rd day here. Um,
Yes, sir.
yes, Miss Cooper.
That was my third day too.
This is your 3rd day. It's the 2nd day.
Seriously, I missed one class
And you missed last week, so
because
um,
I had something to do, and I reached back like 7 o'clock.
yeah, excuses. But anyway, this is day 3, week 15, and I'm definitely excited with the journey. We still in circle theorem, believe it or not. It's gonna be our 3rd part of circle theorem, and today, I just hope it doesn't get too gnarly because as I look at the slides, I was like, wow, this could get out of hand. So we're gonna try to ensure that things don't get out of hand. Hopefully, we understand. If you don't understand, let me know. But this is our 3rd part of it. So far, we have discussed 4 theorems. So today is going to be our 5th theorem. Um, the first 3 are the main ones. The last one I gave you is not a part of the main ones. Um, this one is also a part of the main ones. That is important to know. So let's get into it. Second theorem, part 3. Let me know if you can see the the screen.
What new same today?
Yes, new theorem. Um, okay, so this is another class on circle theorem. Um, we're gonna be looking at problems within a circle, solving them, and this involved the bisector of chords. Now, when we say bisect, right? All right, when we say bisect, what do we mean?
I mean, like split in the
Huh?
middle.
Yeah, to cut in a half, right? And when we say a chord, what is a chord?
Is that like the semi, like that line on top of the circle? That straight line.
Well, a chord is any line that goes from end to end. So, for example, sorry, that's a chord. I mean, it shouldn't come
Yeah.
out. Let me do it properly. It shouldn't come out. It should go from one end to the other end of a circle, whatever end and however long. So this is a chord,
What you want us to write,
this
Mr.
is a
Petit?
chord, and this is a chord right here. All of them are chords. A chord could even go, you know. So those are
It would
chords.
be one like that.
Those are chords. Those are just chords. I'm just trying to get the definition of the way. What does it mean to bisect? What does it mean? What is a chord? So I'll tell you when to begin to write. Oh, this is it right now. So write this down. A chord is a line joining 2 points on the edge of a circle. So this is the formal definition. Now a chord would end up splitting the circle into 2 parts. So this is a chord, and this chord splits the circle into 2 parts, the major and the minor. Which part do you think is the major?
The
The
bigger part.
top.
The top one, so this is the major one. And then obviously the smaller one would be the minor segment.
Minor.
Mm-hmm. All right, so major and minor segment. Oh, I should keep that in. The same thing, if we have a chord, the major segment is the bigger part, the minor segment is the smaller part. Now, the diameter is a special chord, so a diameter is actually a chord. But special chord because it passes through the center of the circle and it cuts the circle directly in half.
Excuse me, Mr. Petit. What if it's split evenly? Both would be the major segment?
Yeah. Like there wouldn't really be, can't call them one minor. They're equal.
Right, Nick?
I don't even know if you would call them one major, one minor. You probably call them equal segments.
Oh.
All right, so that's that. I mean, when you finish writing this down.
Mr. Petit, you want to tell us what to write yet?
I did say write this down.
Right there.
So you need to know a definition of a chord. You need to know what is a major and minor segment, and you need to know that the diameter is a special name for a chord. I mean, a chord. Sorry, you need to know that a diameter is a type of chord. Mr. Bethel.
Hello.
Yes, sir. You alright?
Yeah, I read, That's racing against time,
Racing against time. Okay. What happened on Monday and on Tuesday?
Yesterday, I was thinking about it. I was, sometimes, you gotta step back and see with the bigger picture, I use that to meditate. That to help me find more motivation towards the future classes.
Okay.
Yeah.
Motivation.
I doing it efficiently. Yeah, you gotta balance motivation and hard work. So I use that day as my motivation day.
Sounds like an excuse to me.
That sounds like a good excuse. You sound like you prepared that. You write that speech down.
No, I never prepared that because I didn't know you was gonna ask that.
Man, how could a teacher say no to that excuse, right?
Yeah, I got until 2023, So all this is just reviewed till then.
Why you say that?
Cause I know I'll have to take it again.
Why you think you're gonna take it again?
Because I know I'll have to try to win against my, I didn't call it procrastination, but my hubris.
So, what grade you looking for that you need to take it again, such that?
I don't.
Okay.
These are D.
Hold on, don't move.
I believe we're gonna pass the exam for sure.
Yeah, I just need to take my vacation and then I can start.
I think the pass for sure. Passing, A might fail. I don't know if you get an A, but I believe the pass. So what happened on Monday?
Oh, that Monday was a holiday.
Monday was no holiday. Who can we tell you that lie?
Thank you.
Monday was too hot. I barely read
I feel the same way.
All right, so let's continue. All right, so this is the theorem.
We go back on the place.
What, this one?
Yeah.
We just come off of this. You sure you still need this?
Also, Mr. T, you never answer my question. He sent you what's up.
I answer one or the two, man. At least give me credit. One of the two.
I have it.
Yeah, but this one kind of straightforward, you know.
Oh, goodness. I thought, I was like, that. I just laughed when I saw the question. I was like, wow, that's interesting. But I meant to answer it just, I guess I thought I would have answered in class. I'm glad that you brought it up. I still have to think about my answer though.
All right, I'll give you some time.
Yeah. So this is the fifth theorem that we'll learn. It says the perpendicular bisector of a chord is this isn't the theorem yet. It's just defining what is a perpendicular bisector, right? So the perpendicular bisector of a chord is a line that cuts it in half at a right angle. And I didn't make that straightforward. All I'm saying is that we call a bisector a perpendicular bisector if when it cut the bisector at a right angle. A right angle. You understand what I'm saying? So let me just show you. So this is a chord.
You could draw.
Say it again. How you gonna draw right now?
I was going to ask if you could draw how it's gonna be, but you sure.
We come right now. So this is what we call this. What we call this red line.
A chord.
Chord. Very good. Now, how would we could bisect this chord, right?
Sure.
Yes. And when we bisect this chord, we could cut it such that we have a right angle, and it would be this. So this right here is what we call a perpendicular bisector of the chord. A bisector because it cuts the chord, and perpendicular because it makes a right angle. Right? It forms a right angle with the chord. Okay? So that's why it's called a perpendicular bisector, because it forms a right angle with the chord. Okay? It's very straightforward. So this is the bisector. It's actually called a perpendicular bisector because it forms a right angle with the chord. Straightforward, right?
Yes, sir. You gotta write this?
Yes, my dear.
Mr. T, you don't work with me.
Say it again.
I say you ain't working with me. Because you can tell me what to write.
Oh man, come on, this is, oh my goodness. Wait till
I thought like you said it was so simple, like being I read it. You
no, this is important. It's important. Like some things you know you have to write, and then some things you like, oh, but you're right, I did say I was gonna tell you. It always goes through the center of the circle. Okay, that's a good part. The perpendicular bisector always goes through the center of the circle. Okay, makes sense. Okay, so this is the chord. If we were to have a perpendicular bisector of the chord, it's going to be this one, and it's going to go through the center of the circle, which means it's the diameter. Okay. It always goes through the center of the circle. That makes sense. That's very straightforward though. Because it cuts the chord in half, and if it cuts it in half, obviously it would have to go through the origin to do that. So yeah. So the perpendicular bisector cuts the chord at a right angle. Because it's gonna cut the chord evenly, it's definitely gonna go through the origin. So yeah.
So the perpendicular bisect, it have to be in the middle of the chord.
Because remember, it bisects the chord, so it have to cut the chord exactly into 2 equal parts. You see what I'm saying?
Oh, yes, ma'am. I mean, yes, sir.
Yes, mom. What? When I get a mom?
Yes.
So, Miss Cooper, you in Abaco, right?
Yeah. Miss Betty, you know all day in class I keep saying yes, sir, to my teachers. I hear all day yes, sir. Yes, sir. Then I have to correct myself.
Oh, wow. So how is it with teaching over there? Because I heard things about like low staff, blah, blah, blah. That's true?
Yeah, we still on virtual.
You're still on virtual?
Okay, we on virtual, but they still got us in school. I don't know why.
So y'all in the school building, but virtually connected to the other schools.
Yes, sir. The other people on there too, they in school, but they still on virtual. I don't know why.
The other students, what?
Like the students who online as well with us, they in school, but they on virtual.
Okay. Oh, maybe they still doing virtual?
I wish they could stop like right now.
But you still have some classes in class.
Only language and literature.
Okay.
On virtual, they give us a language teacher.
Yeah, just because y'all have one.
She trying to like do the work what we supposed to do from back then, but the other students for grade 7, they give grade 7 I think a language teacher, but they didn't give us none. So for like the whole term, we didn't have no language teacher.
Wow. I think
So we off with them stuff.
Don't move it. I have it.
Okay. All right. So the chord XY is 10 centimeters. So this is the chord XY. It's 10 meters from the center of the circle. The chord measures 18 centimeters in length. What is the radius of the circle? So that's the question that we have to look at. By the way, remember that the perpendicular bisector of the chord, like we said, if this is a chord, it's the perpendicular bisector. It always cuts the center of the circle. It always goes to the center of the circle, right? So if wherever we draw this chord and we have this bisector, it always going to go to the center. So again, we have this chord. The bisector of this chord, the perpendicular bisector of this chord is going to be through. It's gonna pass through the center of the circle. So here we have another bisector. I mean, we have another chord, and MO. They didn't tell us what MO is, but it looks to me that MO is the perpendicular bisector. XY is just a regular chord, and it tells us that this chord measures 18 centimeters. Using that understanding, what must the radius of the circle be? So OM, the chord, the bisector OM splits the triangle in half. So since it splits the triangle exactly in half, it's definitely the bisector of XY. That's true. All right. And so let's take this triangle. All right. So we take into the triangle MXO. Right. Remember, our goal is to figure out what is the radius of the circle. So let's fill in all the information that we know. We know that this part, right, xm, we know that this part is how much centimeters? Xm.
XM.
XM is how
That's 18 centimeters.
That's 18 centimeters. Very good. I wonder why they put 9 x. No. XY.
No,
XY is
9,
18.
half of the radius.
Yeah, half of the. Since it's half, it's 9 centimeters. That makes sense. Okay. And then what else do we know? MO. MO. How much should MO be? That's this part to this part. Do we know?
10 from the
chord XY is 10 centimeters from the center. So yeah, that makes sense. The chord XY is 10 centimeters from the center. They say that. MO is 10 centimeters. This is a XY is 10 centimeters from the center. So this is the center, and this is the chord. So this distance right here have to be 10 centimeters. That's what they're trying to say. Okay. So we know this is 9, we know this is 10, but the question is, what is XO? And XO is definitely going to be the radius, right? So we don't know what that is, right? So XO is the radius of the circle. Now, the reason why it's the radius, someone asked, well, how is that the radius? But the reason why it's the radius is because, this is the origin, and this is the edge of the circle. So if you're moving from the origin to the edge of the circle, that is your radius. You're trying to figure out what this length is. All right. No, okay. All right. So we're trying to figure out what that length is. What rule can we use to get it? What rule can we use to get the third side, the missing side?
What is used cosine rule for?
Cosine.
That's what you said I do.
Well, you shouldn't use this is an easy one. You shouldn't be talking about cosine rule.
Pythagoras.
I actually used to for cosine rule.
Pythagoras is good one for this. How you know?
Who you mean?
You.
I know because it's showing two sides and we need to find a third side.
Yeah.
It's they scared for your class.
Why is that?
Because they letting the delinquent student answer first.
Yeah. Okay, so a squared plus b squared is equal to c squared. So that's Pythagoras theorem. And so we know that how we get 81? I ain't gonna say how we get 81. Anyone know? What's 81?
9 times 9.
Yeah.
It is a 9 times 9.
Yes, it is 9 times 9 because it's 9 squared, right?
Yes, so then B is 10 times 10. That gives you 100.
Yes, then b is 10 times 10. All right, so what is 81 plus 100? That would be what?
181.
181. So we just switch it. So c squared is equal to 181. Then what are we gonna do at this point?
Square root it.
Take the square root of both sides. So it's gonna be c is equal to what? 13.45. Okay. All right. Good. So we figure out what is the radius. The radius is 13.45. And how did we do that? Well, we first had to use the information they give us. Number one, xy is 10. So sorry, not xy is 10, but it's 10 centimeters from the center. So that means that this space right here, MO, is 10 centimeters. And then we also had to know that the chord, which chord? The same chord xy measures 18 centimeters in length. So if we wanted to know xm would be 9 centimeters. All right, 9 centimeters. And then to find the radius, we just have to use Pythagoras theorem. So let me know if I need to explain it again, or I could just move.
You can explain it again, please.
No problem. I know I anticipated it to be some sort of interesting. So you see, MO right there, if you understand, like MO is 10 centimeters. We know that. And we know that because it says that the chord is 10 centimeters from the center. So from the center to the end of this, from the center to this chord xy, that's 10 centimeters. That's what we say. All right. And then from the entire chord itself measures at 18 centimeters. So all of this right here, all of that is 18. Okay. And we don't want all of xy. We just want a portion of it, which is from x to m. Right? From x to m. So what is half of 18?
9.
9. So you know this side is 9. This side is 10. So since this side is 9, this side is 10, we need to find what is the missing side, which is this one. And so we use the Pythagoras theorem, which says that a squared plus b squared equals c squared. We get 81 because 9 times 9 is 81. We get 100 because 10 times 10 is 100. That equals to c squared. And then 100 plus 81 is 181. So we get c squared equals to 181. And then we take the square root of both sides. That's going to give us c equals to 13.45. And so that's how we know what is the radius of the circle. Right?
Don't move it.
No problem.
I understand it now.
Okay.
So, I want you to myth bust something.
You want me to what?
Myth bust something.
What is it?
Someone told me that high school math was worse than college maths because college maths was actually fun.
What level of math did they go to in college?
They say they didn't go up to pure maths, but I guess the standard.
Did they go up to calculus 1 at least?
Probably, but they say they didn't like have a pure maths something, you know.
Bring it up? Okay. One moment. Give me 2 seconds. By the way, I gonna myth bust it, but take this question down and try it. I have to run and move my car up on the parking lot. Apparently it's blocked. It's in some one way, I guess. Give me one moment.
Okay.
All right. Did we get any answers?
I ain't finished. I was drawing the shape and trying to read the question.
Okay, let's try it. So it says AB is a chord. So this is a chord again, AB. And with which O makes a triangle. So O is the, what do we call O?
The perpendicular.
O.
Oh.
Not O as in O, I understand, but O.
The origin.
The origin. Very good. So O is the origin. The radius of the
The
circle.
arm is the perpendicular thingy.
OM would be the perpendicular bisector. The radius of the circle is 5 centimeters, they tell us. So that means that AB is 5 centimeters. AB measures 8. Why does AB? Oh, AB, the chord AB measures 8 centimeters.
Yeah.
And then calculate distance OM. So OM would be this distance from here to here, or would be this distance. That's what they're trying to say. This would be this distance. But that's Pythagoras theorem again. We know what is OAO, so let's do it again. So OM splits the triangle directly in half. That's very important to know, with that perpendicular bisector. Remember we said that the perpendicular bisector, remember, that's the application of this theorem. The perpendicular bisector always goes through the center of the circle. All right, so that's an important note. Okay. All right, so if we go back here, if we take this triangle out, then we would have this triangle. And why do we have a right triangle there? Why do we have this right angle there?
Because it's perpendicular.
It's the perpendicular bisector.
Yeah, it forms a right angle with the chord, right? Let's follow the information that we do know though. AO should be how long?
Who?
AO should be how long? AO. Think about it. AO should be how long?
4 centimeters.
Why say 4?
10.
They want radius, right?
AO.
Oh.
They don't want. They asking us for. They want us to give.
My
OM,
God.
but we want AO. AO is a specific name that we give to AO. Remember, any line that goes from the center of the circle to the edge of the circle is the radius. So they want this. So this is the radius. Now they already tell us what the radius is. How much is the radius?
5 centimeters.
5 centimeters.
5 centimeters. So AO is 5. Okay. Now, AB is 8. So that means this entire thing right there. AB is 8 centimeters. So the entire thing is 8. The whole thing is 8. So what is AM?
4.
4. Because it's half of 8, right? Now, the question is, what is OM? And that's what we're trying to figure out.
The Pythagoras theorem.
Yeah, Pythagoras theorem. So it's going to be, we read all the information we know, It's going to be, so we switch it because Pythagoras theorem is Pythagoras theorem is c squared equals to a squared plus b squared. That's Pythagoras theorem. But when we want to find what a is, because we don't want the hypotenuse, we want what A is. So we're going to send B squared over. So it gives us that C squared minus B squared is equal to A squared. And so that's why this looked a little different than how it usually is, because we had to rearrange it. And so A squared equals to C squared minus B squared. That's what we use it.
What is it, we have it?
What I'm saying is we're looking for we didn't remember the previous question we did. We used looking for the longest side. So we had to use C squared equals A squared plus B squared. So we had to add the sum of the squares. So we had to square the sides and then add them. But here we're gonna subtract them because we're not looking for the hypotenuse. We're looking for this side. So we have to subtract them. Now you add them. The way you know that you have to add them is if you're looking for the hypotenuse. So say for example, we're trying to figure what is the longest side. This side, the longest side right there is always C. It's always C. So when we're looking for that, then we add them. But when we are looking for another side other than the longest side, other than this one, then we subtract them. Okay, so that's how it works. Does that make sense? Or I should explain it again.
You can say it one more time.
Like if you look at the previous question we did, right? Remember what we were looking at? We was looking at how to find we was looking at how to find which side. This one, right?
Yes, sir.
Hypotenuse.
Wasn't that the longest side?
Yeah, yes, sir.
Yeah. So if you're trying to find this side, then you have to add them. Right? But if you're trying to find the next side, this one or the other one, then you have to subtract them. So in this case, yeah, in this case, we are not looking for, we already know 5. We're not looking for this major one. We already know what that is. We know that it's 5, right? So we're looking for this side, the one in purple. So we have to subtract these two. So square them and then subtract them. All right?
We just manipulating the formula then.
Yeah, we're just manipulating the formula. All right, so it's going to be 25 minus 16, which is going to be what? 25 minus 16 is 9, so it's A squared equals 9. And take the square root of both sides. A is going to be equal to
3.
3. No. Okay, so that's that. Any questions on this? Please let me know if you have any questions.
Let's see, where you? Oh, never mind. Square. No.
All right, let me know when I can move on. Hello?
Yes, sir.
I can
So
move on. I can move.
I would say so.
Okay.
Yes, sir.
All right, so that was another theorem. I'm not gonna continue with this one. I think this one is pretty straightforward. Uh, Remember I told you that there's about eight, right? Eight theorems that you need to know. And so I'll just flash them in front of you now. I'm just gonna discuss it. And then we're gonna look at some actual questions from the exam. Let me use Corbat Math. I think they have a good one on this, which was pretty good. I liked. Okay, so some of them we already saw before. So like I said, it's this is the main eight, all right, that you need to know. All right, so this one we saw before. This is the first one we saw. The angle in a semicircle is 90 degrees, which means that, if this is the diameter, diameter cuts the circle into two equal parts. This angle right here is going to be 90 degrees. So that's the first one you need to know. The second one that we did already was that the angle at the center is twice the angle at the edge. So if this is 120, this is 60. If this is 100, this is 50. If this is 40, this is 20, and so on. Do we remember these two?
Yes, I remember the second one.
Okay. The first one we did on Monday. And he was on
Yeah,
vacation.
the day was the
No, the day he was on vacation. All right. Then we have this one, which we learned yesterday. Sorry.
bow tie.
The bow tie. The bow tie rule. And so the bow tie rule basically says that angles in the same segment. I like this one. We didn't really emphasize this, but from a common chord, I said that subtended by the same arc, but same difference. From a common chord are equal. So basically, you look at the tips. So if this is 32, this will also be 32. If this is 23, this will also be 23. They're equal. All right. That's the third major one you need to know. Then we went on into
To
this.
see
Mhm.
that line, right? You see the line by the bow?
Yes. Yeah.
Yeah. Why do you have that there?
Um, that is not they just did that is just another way of understanding the bow tie rule. But I think we already explained the bow tie rule well enough for you to identify it.
Yeah,
Now,
I identify it, but like how I draw mines, I was confused. I was like, what this line is like something supposed to be here?
it's just a chord that they draw, so don't get confused about the line. It doesn't change the rule.
Okay.
All right, then we have what we call the cyclic quadrilateral. What do you mean when you say cyclic quadrilateral? You remember from yesterday?
The opposite.
Yeah,
What is a cyclic quadrilateral? Remember?
you know,
Say it again.
that's the quadrilateral but drawn inside a circle.
Very good. So the cyclic quadrilateral is a quadrilateral drawn within a circle. So this one right here, the one in red, is a four-sided figure. It's a quadrilateral, but it's drawn within a circle. So we call it a cyclic quadrilateral. And we say that the opposite sides of a cyclic quadrilateral must add up to what?
180.
180. So 70 and 110 gives us 180. 100 and 180. Sorry, 180 gives us 180. So this is a very important rule to know. Okay? So this would be the fourth rule that we learned. Now, the fifth major one is what we did yesterday, if we did just now, and we said that the radius through the midpoint of a chord will bisect the chord at 90 degrees. So if we have a chord, right? A chord is a line that touches the circle from end to end, right? And if we have the radius, so this starts from the center and goes all the way down, we call this the perpendicular bisector, right? The radius through the midpoint of a chord will bisect the chord at 90 degrees. So this will always be a 90 degrees, right? So this is a perpendicular bisector. So if this is the chord, if this is the center of the circle, and this is the end of the circle, and we have the chord, and this being the radius, it will always bisect the chord and form a 90 degree, right? So that's the rule stated in a different way. Now,
What that one? What?
now we come into that. So this is another one, another major one to learn, that the angle between the tangent and the radius is always 90 degrees. So remember, the tangent is a line that gives the circle a kissing blow. All right, it's basically a line that touches the circle at one point. All right, so this, if you find that your tangent, right, and your radius touches and form an angle, that angle will always be 90 degrees. All right, so where your radius and your tangent touches, that will always be a 90 degrees, right? And that's the sixth major theorem to know. The seventh major one to know before the last one, this one is called the alternate segment theorem. All right, it basically says that the angle between the chord and the tangent is always equal to the opposite angle within the triangle. So this green line is the tangent, all right, and this red line is a chord. Okay, now the chord makes an angle with this tangent, and this is 60 degrees. Now this theorem says that if this is 60 degrees, you look at the opposite angle in the triangle, and that will also be 60 degrees. Right? That's what this is saying. And the same is true for the other side. So this is the chord, part of the chord, and it forms an angle. Sorry, this is part of the tangent, and it forms an angle with the chord. And so this angle right here, which is 70 degrees, will be equal to the opposite angle in the triangle, which will be 70 degrees. All right, so these two will be 70, and these two will be 60. That is the alternate segment theorem. Okay, and it's important to know that. And then the final theorem of all that we learn would be these two, talking about the tangent. So if we have two tangents, right? One tangent, right? You said the tangent touches the circle at one point. It gives the circle a kissing blow. So this tangent, if we have this tangent and another tangent on the circle, the two tangents, when they connect, right, they would form two lines which are equal. So the tangents to a circle from the same point will be equal in length. So the tangents to a circle from the same point will be equal in length. So this is the same point that they share, and where this touch and where this touch, this will be, they will be equal in length. So these are the 8 theorems that you need to know for your exam. The first deals with the semicircle, right? My bad. The first one deals with the semicircle. The second one deals with the one at the center and the edge. The third one is the bow tie rule. The fourth one deals with the cyclic quadrilateral. The fifth one deals with the tangent and the radius. The sixth one deals with the tangent and the opposite angle in a triangle. The seventh one deals with two tangents, and the eighth one deals with the radius of the circle and the chord. So when you encounter a question on circle theorem, all of these theorems you have to keep in the back of your mind ready to use and apply. All right, and you have to figure out, okay, which one is really appropriate, which one really makes sense that we could use. All right, so we'll go now through some past papers and look for some circle theorem problems.
You have a 1 in 8 chance of getting it.
1 in 8. I mean, I wouldn't say 1 in 8 chance. No, I wouldn't say that. Because sometimes they'd put 2 in the same thing or 3. You know what I mean? And, let's not just get full of ourselves because, all the geometrical principles would apply. So corresponding angles, alternate angles, angles at a point, angles on a straight line, angles in a triangle, all those theorems, or it's not theorems, but all those geometrical rules matter. All right. Okay. Hey, Nancy. All right. So let's go through. Let's go to past paper. So we just
When
finished.
circle theorem,
Say again.
we ain't write no more notes for them, or we just like running through them.
I just run through them. I just run through all 8 one time. You wrote them, right? I hope you all write them.
No, sir.
You didn't write down? Oh my goodness. Okay, let me give you a chance to write down. You should have 1, 2, 3, and 4. You should have those 4. From
I don't.
You don't have them? Okay,
I don't have one.
you don't have 1. All right. So I can give you a chance to write them down. But you have to have all 8. And we just finished talking about them. So what I'd suggest that you just take a screenshot because I don't want us to take too long.
Okay.
Take a screenshot of this 4 and then the last 4 that we just talked about.
I got the first 4.
You got the first 4? Okay, good. Now let's look at the last 4. These are all the circle theorems that you would need to know for your exam.
Got it.
I can't think of any other that they would be testing you on. Like I said, all the other ones apply. All the other principles apply. Okay, so all the other ones from geometry that we talked about, the vertically opposite, all of them apply as well. Okay, so let's go. Bgcse pass what? Math past papers. I want us to look at. It doesn't matter which paper we go through. I just want us to go through the papers and see if we find any circle theorem problems. So as I click, let me know if we see any circle theorem problems, so we can look at it one time. All right, so it shouldn't be in paper 1. I don't anticipate it in paper 1. This is not circle theorem. This is just regular geometry. So all of these geometrical principles, where you would be seeing them in circle theorem, like they are fair game. Okay, so it should be somewhere in paper 2 or paper 3. So let's look. I don't see none. I don't see none. So I don't see it in paper 2 of this year.
Can I send you a picture of one blip?
What year that is?
That's 2021.
Okay, good. Send me the picture. Okay, I don't see it in this year at all. So they didn't test that this year, that year at all. So 2019 they didn't test it. Okay. That's interesting. They didn't test it at all in 2019. So now students, if you didn't know circle theorem in 2019, you still gotta get an 8. That's cool. Okay. Alright, so they didn't test it in 2019. Did they test it in 2018? Okay, so alright, so 2018. This is what? Do we see any circle theorem? 2018. Okay, circle theorem. Yep, there's circle theorem right there. All right, so I'm gonna do Ricardo's question and then I'm gonna okay. So it was tested in 2018, paper 3. So we're gonna look at this, right? And we are gonna understand all of the oh look at it again. I wanna see the points. I wanna see the points allocated, Ricardo. So send me it again, but send me it with the marks. Okay. So while he's doing that, let's look at this paper. I'm excited. This is paper
You
3.
know, I just popped in. What exactly are we doing today?
Oh, you came late.
Yeah, sorry.
Mm-hmm. Was on vacation. I understand.
If only if that was true.
If only that was true. All right. But we're glad you made it. I was wondering if it was coming. Because we finished circle theorem.
What?
Yeah, we do all the theorems.
Without me?
That's what I was saying. I was like, wow. I was like, she going and she's
These
finished.
videos just be long to watch, Mama. Now I can't look at no screen.
All right. Let me do a quick review then, so that you can come up to speed of what we're doing. So the ones we did so far, you already know. So you familiar with this one, right?
Yes, sir.
This one,
Uh-huh.
bow tie rule.
Yeah.
Okay. Cyclic quadrilateral.
Yeah.
Good. Okay, so what we did today was we started off with this one, but I'm gonna start off with this one. This one deals with the tangent of a circle and the radius. So the tangent is basically a line that cuts the circle, but it cuts the circle at one point. So it gives the circle a kissing blow. All right, so this is the tangent and this is the radius. So this one involves the tangent and the radius of a circle. This theorem says that once the tangent and the radius of a circle connect or forms an angle, that angle will always be 90 degrees. So that's what this theorem says. Once
Okay.
the tangent and the radius of a circle touch, it will be 90 degrees. Okay.
Okay.
The second one that is important is the alternate segment theorem. It basically says that, hey, if we have a tangent, right, and the tangent makes a angle with the chord, this angle that is made, right, will be equal to the opposite interior angle of the triangle. So this angle that is formed with the chord and the tangent will be will be equal to the opposite interior angle of the triangle. So if this is 60, this will be 60. If this is 70, this will be 70. You see that?
So it's like crisscross then.
It's like crisscross, right? Almost like the Z thing going on,
Oh, yeah.
right?
Okay. I see that.
Um, yeah, that one straightforward. This one says that if we have two tangents, right, and they meet at a point, these two line segments will be equal. That's all this says. If we have two tangents and they meet at a point, these two line segments will be equal. Okay, that's what this theorem is saying. And then the final theorem is that if you have the radius of a circle and it crosses and touches a chord, it will make a 90 degree. Okay, so the radius, when it crosses the chord, will form a 90-degree angle. So these are our theorems, our 8 theorems. Okay, so what I'm going to do is I'm going to circle theorem. I just want an image that has all 8 so that we can have it on the side while we are looking at um, this question. So this have all 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this have all 8. The perpendicular from the center of the chord bisects the chord. The angle, yeah, this have all 8. So while we're looking at this question, we need to have all 8 in our minds. Okay. So I'm just gonna have it somewhere on the screen. So let's have it say somewhere. somewhere in the corner so that we can have it, right out. Good. So in your mind, you should have these pictures in your mind. When I was learning circle theorem, the only thing I needed, to be honest, was a picture of it. I didn't even remember. I didn't even focus on so much on the words. Once I had the picture, I knew what was going on. Right? I don't know if you were like that, but all I needed was the picture. Okay? Because the picture, you could always mimic what the picture does. So now let's think with ourselves. Which one of these theorems you think would be applicable? We didn't even know what we're doing, but like, which one you think would be applicable?
The seventh one with the tangent.
Seventh one, yeah. I think this might have a part to play because it seems right because we have a tangent and another tangent and it meets at a point. All right, so maybe that would be something that we need to know. Okay, so let's use the result of that rule already because, well, it tells us that these two lines would be equal in length. All right, so if these two, oh man, this is so easy. If these two lines are equal in length, that means that we are dealing with an isosceles triangle because this triangle right here, triangle W,
Y and X equals
and
180.
X. Yeah, the triangle W, Y, and X. We know that this is a triangle, right? And so we know that we're dealing with isosceles triangles. So that means that, like I said, these two lines are equal, but more than that, these two angles are equal. All right. So that tells us how to get M1 with one go. M would be equal to what? Think with me.
With M.
Uh-huh. How we get M?
180 subtract 58 divided by 2.
Very good. Very good.
But isn't that Y? Isn't that entire thing Y?
No. Y. Don't worry about Y. Y symbolizes the point. All right? Not the angle. All right?
What?
Yeah. Y is the point. See, we talking about capital, and that's one thing, students always is get mixed up. The capitals, especially in circle theorem, they symbolizes the point. So this is the point W, the point O, the point X. Those are talking about points. All right?
But didn't you just said that it was WYX? I figured.
Yeah, that's what the triangle is made up of. The triangle is made up of, we name the triangle W, Y, and X. That's how we always name a triangle based on its vertices. These are vertices of the triangle. We're not talking about the angle themselves because, okay, if we say that this is, and I mean even so, but we can't call this angle Y because then what angle are you talking about, right? The letter, the lowercase letter indicates what angle that we're talking about. And indeed, if we're looking at this triangle, we're looking at angle M58 and whatever this one is. And so these two angles must be equal. They must be equal. You see that?
What you saying, Mr. Petit?
These two angles must be equal. Do you understand that?
So,
Yeah, that's straightforward. So it's going to be 180, like Ricardo said, minus 58 divided by 2 because we are sharing. Once we already figure out what 188 minus 58 is, we have to share it between these two angles. Okay, very good.
well,
Go ahead.
I thought once you get that, you just put it, whatever you get for one, you put on the next one.
But think about it. Let's do that. Okay, so let's do what you tell us to do, right? So if we do that, so if we say 180 minus 58, right? What you get when you get 180 minus 58? So do that for me.
122.
122, right? So
Yes, sir.
if M is 122 and this one is 122 and this is 58, how could all of them equal to 180?
Oh, okay.
You see that?
Wait, you mean 122 on both sides plus the 58?
Yeah. How that could be how that could be equal to 180?
It can't. It
Yeah.
can be more than that.
That's the problem. Okay. So we have to share the 122 with both angles. So therefore, those two angles would be the same, but they can't be 122. 122 is what we're gonna share in between them two. Okay. So 122
Okay.
divided by 2, which is what? Which is what?
61.
61. Very good. So this is 61, and this is also
61.
61. Any questions on how both of them are 61?
No, sir.
No. Okay, good. Okay. So how are we gonna get n?
What'd you say?
How are we gonna get n? So we know this is 61, but how are we gonna get n? This angle right now. Anyone?
Are you gonna minus 61 from 180 to get n?
Why 180?
I don't know. It's quite. I don't know.
Think about it. Use your theorems. Use your theorems. Which theorem you think would be appropriate at this point? So the theorem that's going to be appropriate is this one. Because think about it. Look at this. We know that this is
So you instead of 30 and 180, you can use 90.
exactly. So we know that if we have a tangent and we have the radius, how do we know that this is the radius?
Because they're coming from the origin.
Because they're coming from the origin, very good, and they're touching the point on this on the circumference. So it's definitely the radius. We know that the angle formed between the radius and the tangent is always what? 90 degrees.
90 degrees.
90 degrees.
Very good. So n plus 61 must equal to 90 degrees. Okay? And so that means that n is going to be equal to what?
Mr. Batista, I was thinking 90, but I wasn't using that one. I don't know why.
Okay. So n is going to be equal to what?
29.
90 minus
61.
which is what?
29.
29. Are we good? Don't forget the degree.
What about the degree sign for the top?
Right, are we good with this question?
Yes, sir.
Sure.
Alright, good. So this is as much as it gets, right? Circle theorem, I could be honest, is not heavily tested on your exams. They usually bring one question, and that's it. And so, and that's what? How much points? 6 points. Mercy.
9 points.
3, 6. How 9?
You clip out one.
Will be more parts.
Clip out 1? I clip out 1? Let's see. Oh, that one is not a circle theorem, that's polygon. This enter into something different.
Okay.
Okay. So yeah, circle theorem, 6 points. 6 easy points that you can easily get, right? You don't want to let these points go. All right. Okay, so let's move on to another one. This one was 2018. I should put this in my slides, my math classes slides.
We're gonna do the one from Ricardo.
Yeah, we're gonna do that right now. Did he send a new one? Okay. Okay. Okay, so let's consider this question. Okay, so it says in the diagram below. It's a nice question. What rule you what rule you have?
The time.
Yeah, bow tie. I really see bow tie. That's why I like with these exams. Like when you look at them, all you gotta do is smile and say, "Ah, my, look what we just learned, eh? My,
Hey, Miss, could this be like two theorems in one?
yeah, you see the other theorem, right? You see the other theorem, right? I see it. What other theorem you see?
The same one. I don't know what the name, but this one right here.
You mean
Put
the
on the
one
screen.
with the two tangents, right?
Yes.
Yeah.
That was the first one I see. I didn't even see the bow tie, and that's my favorite
Oh, you
one.
want to see the theorem? Yeah, you want to see the theorem.
I just realized that.
And Miss Cooper, I always smile when I hear your voice, boy, because I'm like, you in grade
Hello.
8, boy. You in grade 8. For heaven's sake, you in grade 8. Wow. What you doing knowing with circle theorem? How you be in math class? I need to know how you be in math class. That's his class. How you
I mean,
uh-huh.
let's just say I talk a lot.
You don't give them teacher a break.
But I just get mad when they don't pick me. Like this be like give somebody else a chat. But if they ain't talking, what you want me to do?
Yeah, exactly. Exactly. You better not get anything wrong in your math exams.
No. Okay, would get.
Okay. Because I would personally sail over to Avoco and take off my belt.
I just like I overthink something.
Okay. But yeah, man. Very good. Alright, so in the diagram below, AB and BC are tangents to the circle. Okay, so AB, they telling us that they are tangents. AB and BC are tangents. So we already know that we're using this rule for sure. At points A and C respectively, determine the size of the following angles BAC. Let me let y'all do it. I can give you 60 seconds to tell me what A, B, and C are. So 60 seconds on the clock. Try it. 60 seconds. What is it?
What do you mean by the size?
The size, they mean the measure of the angle. Like in terms of degrees.
Like the interior angle, right?
Yeah, certainly.
Like the total.
A, B. Oh, here they play a smart. They ain't give us no interior angle, so they mean in the that's true. A Oh, you gotta be careful. You gotta look at what triangle they talking about. So you're talking about the interior angle of a certain triangle, and they give us the letters to indicate. All right, that's time. All right, so let's do A.
I just finished drawing though.
Let's do A. So anyone got an answer for A?
I still was drawing it.
I think we do the same thing we did last time with the share,
Sure.
divide the angles by 2.
Yeah.
After,
Yeah, so I'm glad that you said that because first of all, let's note what triangle we're talking about. Triangle B, A, and C. So we're looking at this particular triangle. All right, and so we know that based on the theorem, if we have these two tangents, right, they're gonna be equal in length. All right, and so that means that we're dealing with isosceles triangles. So we're looking at something like this, and so they're gonna be equal in length, and so and therefore these angles are gonna be equal. And so 54, what we're gonna do? Are you surprised this is only for 1 point? In the previous exam, this was for 3. But this is gonna be equal to, that's crazy. He's so selfish this time. It's gonna be equal
180
to
minus
180
50
minus
over 2.
54 over 2. Which is gonna be equal to what?
Um, 126.
Divided by
2.
which is what?
63.
63. Very good. So this is 63 and this is 63. Miss Rackley, you understand?
Yes, sir.
Miss Joseph, you get it?
Mm-hmm.
All right. Caro and Floyd, understand?
straightforward.
Straightforward.
Yeah.
All right. I wish Mr. Meadows was there. I really wish he was there. Okay. Angle A, E, and C. What would that
It's
be?
90.
Say it again.
It's 90.
I gotta be careful, Nancy. Do we know that AC is the diameter? So we can't say it's directly 90 degrees because we don't know if AC is the diameter. So you can't say that. You can't make that claim. E. Anyone have any ideas for E? A.
Could it be the alternate segment theorem?
Okay. Alternate second theorem. Okay. So let's look at it. So we're looking at this is A, E, C. So A, E, and C. A, A, E, C. Let me redraw it again. Okay, so we're looking at this triangle. A, E, and C. So this is a triangle that we're looking at. This is it now. Mm-hmm. The alternate angle theorem says that if we have a tangent and this is A, this must also be A. If it goes across like so, that didn't have to work. 63 then, because it's opposite to E. You see that?
Yes, sir.
Yeah, 63. That way. That's the only thing we got going for ourselves. We can't use any other thing. Because we can't use none of this. No, that works. This is not even a cyclic, so we can't use that. We have this. This might be useful, but the problem is we can't use the same radius. We don't even have a center. This one, we don't even have a center, so now we can. So only thing we have for ourselves is this one. So it'd have to be this one, 63. Alright, so if this is 63, then we need angle EAC.
Mr. Petit.
Why is it
We doing
60?
B or C? We doing B or C?
We doing this. So this is 63.
Where does 63 come from?
Remember, we got 63 from this one. So 63 was A was 63, right?
Yes, sir.
But they is the same thing. They are the same thing because remember we say they share the same angle. It's isosceles triangle, so these two must be the same.
Oh, wait. So what E is?
Now E must be 63 too, because if we look at this theorem, if we have a chord and we have a tangent and we have an angle in here, it's going to be opposite, equal and opposite to, it's going to be opposite to the, it's going to be equal to the opposite interior angle of the triangle. So if we look at 63, this is opposite to this one. I don't know if you can see it, but that didn't look right though. Let me see. Let's look at I don't use that. Let's use something. Let's do something like this to get a feel for it. Alternate angle theorem. Okay, so this and this and that and that. Okay, so this and this and that and that. Okay, so if we have the tangent, this one would be. I'm trying to find a consistent basis to make our measurement. So could we say that if we draw an angle in the middle, that this one is this one, that one is that one. So if we have something like this is going to be equal to the one at the far end. Yeah, this is for real. If we look at what we have, right? This one in underneath is equal to the one on the outer. Alright? And so let's go back to this. What we have. Yeah, we have it exactly. This one in the underneath is equal to the one on the outer. Yeah, that's correct. Pretty good. And then this one here, if we had it out, would have been equal to A. Alright, so yeah, that's 63. Because of the alternate angle theorem. Because this is 63, this one is also 63. Now, we want EAC. EAC.
Hold on, Mr. Petit. How you get 63 again?
For what? For what? B or?
B.
Okay, if this is 63,
Mm-hmm.
this one must also be 63. Because look, this is a triangle here. Right? You see the triangle there, right?
Yes, sir.
You see the tangent.
Yes, sir.
Okay, you see the angle here? That's 63. So what angle is opposite to this?
Up where he is.
Yeah, up where he is. Ain't nothing else. So that's the same idea here that we have. If this is
Oh,
the angle here, this is the opposite one. If this is the angle here, this is going to be opposite one.
okay, all right.
Okay, so that's true. That's fair. That's true. Now EAC is going to be this one. So EAC, so that's EAC. But this time,
Kind of like the same thing,
it is the
almost.
same angle. It is the same angle. It is we looking. It is the same triangle. Just looking at different angles. We're looking at this guy. All right. So what would this guy be? All right. So that's straightforward because the tangent is going to
70 degrees.
that can't be 7. That's too big.
That's too big.
The tangent is going to continue. If we continue, our tangent is going to look like that, right? And so this one is going to be equal and opposite to this one. But this guy right here, we can easily figure that out because we know that they're on a straight line. So 63, 47, and 90. So sorry, 50, 67, 47, and this guy is supposed to all equal to 180 degrees.
Oh, I got 70. I only used 63 and 47.
And subtracted from 180.
Wait, 63 and 47, right?
Yeah.
I guess 70.
It's 70? 70.
Yes, sir.
Okay. That's correct then. So 63 plus 47. Yeah, it's 70 for true. So 180. So sorry about that, Mr. Forbes. I thought that was...
Yeah, be sorry. I was confident. I just waiting for you to explain how it is not.
And at the angle, you could add 63 plus 47 to get the third angle also.
63 plus 47. What third angle? You mean A?
Yeah, because it's in a triangle, so don't you add up the two ones in a triangle to get the third angle?
Mano, wow. That's even better. That's so true. That's so true. Very good observation, Nancy. Very good. I mean, I knew that. I just was doing it another way, Just, but yeah, I honestly didn't see that. But you're right, it is true. I was looking at this theorem, but you're right, because if we look at 63, 47, this angle is inside of it, so that's just...
With the teeth, it's pretty good.
Hello, y'all hear me?
Hello?
How we hear you?
Oh, okay. Y'all wasn't hearing me before?
What's up?
No, yeah.
No?
Either y'all or so.
Oh. All right. What I was saying is, so where did I end?
You say Nancy idea was a great idea.
Yeah. Can you see my screen or I have the...
Yes, I can see it.
Okay, good. Okay, so yeah, I was saying it is a good idea. I did see that. But it's a very good idea and it's probably the most straightforward idea. And so I'm gonna abandon that previous one because it's just more straightforward. So this angle here and this angle and A must add up to 180. So it's gonna be 180 minus 63 plus 47. It's gonna be what?
Yes, girl, blurry.
And the same thing we do?
Yeah, the same thing we did.
Yes, blurry. Blurry.
And blurry.
Yes, sir.
I think I know what's happening. Too much people on this thing. See, that's why you do not give out your password. Change it. Oh my goodness. That shouldn't have been recorded. Sorry, people who's gonna watch this in the future.
It came back now. It came back.
Came back. Still,
Yes, sir.
I need to change this password. That's why you don't. I see you always stick the intuition. I say no, I'm not gonna give it out. And
You can cut everybody off the internet.
I have to change it. I have to change it because it interrupting my precious time with you all. I can't have that.
Yeah, that's true.
All right, so 70, right? Okay, so A, D, and C.
Yes, sir.
A, D, and C. So D. So I hate that we have so much things on the screen. So move this. Put it say here. And so we need ADC. So we're looking at which triangle? A, D, and C. Good. So you want?
But the,
Yes, sir.
no, I just thought about something brilliant just now, right?
Yeah, what's brilliant?
I got an epiphany just now. It's so brilliant.
Yeah.
I was thinking about this, and I say, you know, an exam, instead of bringing the traditional calculator, I could just bring you. All you got to do is identify as a calculator. And that's all you got to do.
Identify as a calculator. I nearly as good. But D is simple. I mean, we can see it from here. What is D? I think D is simple. We don't even know.
Degrees.
D is what? Come on, people. What is D? D is very straightforward. D is this guy.
Just D4.
Okay. This is very simple.
Is that the bow tie theorem?
The bow tie theorem. Very good. Which is what?
Angle
63. 63 then.
Very good. Very good. All right, so there you go. 4 points. 1, 2, 3, 4. 4 points. Don't lose out on these easy 4 points. Any questions for me?
What's up?
How do you all feel about circle theorem in general?
In that part.
With these set of rules, I don't mind it. But when you said they could come with like the other rules too,
Yeah, they could come with other rules when we saw that earlier. They came.
Yeah, with the vertically opposite thing.
That could come as possibility. But you know, Bgcse is not meant to kill anybody, so so they should play fair. Let's do this one. This is 26 minutes. All right, 60 seconds on the clock.
Don't forget we can write it too as well.
And it begins. You should do it first and then write it as we do the answers together. Eh? Makes sense? All right. Time has begun. Give me a few moments. I gotta get. Give me a few moments. Try it.
BC is 62, right?
Yeah.
So that's an angle on a tangent, and it's the opposite of C.
Continue to teach, Mr. Bethel. No problem. No problem. What you teaching?
Okay. I lock it in 62. Final answer.
Document 62. Okay, so let's go with A. What is A? What is angle A? Wait a minute, sorry, what is the answer for A?
62 degrees.
62 degrees. Anyone else agree with him? Why we say it's 62?
Opposite of.
Because of the alternate angle theorem, right? Not alternate angle, because of the alternate, what do you call that theorem again? Alternate segment theorem. This third one. I mean, sorry, this final one. Alternate segment theorem. Good. All right, BAC. So A. So what is this angle? Yeah. Oh my goodness, it's too easy.
Paper about 180 minus
That's a giveaway, man. That's a giveaway.
2 divided by 2.
What you say, Anansi? What do you say, Nancy?
Let's add 100. 180 minus 62, and then you get. Can you divide your answer by 2?
Okay, very good. 180 minus 62 divided by 2, and it's going to be equal to
118.
There's a theorem like a normal theorem, or there's a new one?
which one?
This ain't B1.
No, it ain't a new one.
Or it's just like parallel.
This is just like one of the ones.
I mean, not parallel. Isosceles.
Like, yeah, that's one of the ones you should know. All right, angles and we share them once we have the same once the two sides are equal, we're gonna share them. We're gonna share the.
A is 59 degrees.
So this is. So A is 59. And we want CBE. So CBE, that's going to be this angle here. COT. Too much. It's only using one hand. Trying to be lazy. CBE. So that's this angle right here. All right. So this angle is going to also be 59 because of the alternate segment theorem, because of this. Because if we look carefully, this and this, they are opposite each other. Okay. So that's what we go. So we look at. Very good application. So this is 59.
This will take, can you, okay, wait, you said it's 59 because.
Yeah, it's 59 for true. Wow.
What you minus it from?
I know the minus one. What do you mean?
Is there any other way to get 59?
There is another way to get 59.
What's the
angle on a point, right?
Angles on a straight line. So we know 62
and 59 equals 180.
Yeah.
Okay, just I don't like the first one.
You don't like the first one? That's a straightforward way.
Yeah, I can't see how you find that one.
That's literally this. That's literally this application.
But you say the second way?
The second way, okay, so if we look carefully, this is the Miss Cooper, I love your questions, man. Keep it up. So the second way is if we look at this line, right? Right? This is 62. Okay. This is 59. We just saw that. And then we're trying to figure out what B is, what this one is. But all of them supposed to add up to 180. So we just would say 180, right, minus 62 plus 59, because angles on a straight line is 180. It's going to be 50. You see what I'm saying?
Yes, sir.
Okay.
I don't believe that, Mr. Petit.
You don't believe what?
I don't believe you use that alternate segment theorem.
I did.
I can't see it.
You can't see it. It's so clear. It's so clear. I mean, I don't know what to do. Like, look, this is 59. We knew that there was 59. And then it's literally the tangent line. This is the angle, right? This is a chord, remember? We have a chord and we have the tangent line. This have to be alternate to one of the interior angles inside this triangle. It can't be 62 and it can't be this one. So it have to be 59 here.
All right. I get it.
You have to get it because it's right.
I get it, but I can't see it.
Oh my goodness, it's clear as the day. But yeah, it's because if you look at what the theorem says, you have a chord, you have a tangent, you have an angle, and you have an opposite angle. What more you want the theorem to say? You have a chord, you have a tangent, you have an angle, you have an angle.
I understand.
Alright, any other questions from? Alright, I think we have time for another circle theorem question. And then I'll leave y'all with a homework. Let's see if we can find another circle theorem question from past papers. We only have one paper. No, we can't look at 2015. So at 20, can't look at 2014. We only have 1 and 2. Anyway, maybe it'll be there somewhere. Okay, so let's look at 2014. It's usually not on paper. This is Bgcse. That's why it's a problem. I'm still looking at Bgcse. Boom, 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 Bgcse. Let me just find out. Oh, it was B here. Okay, so let's look at 2013. See if there's anything in there. Did we look at that one was 2016? So let's look at 2014. Let's see if there's anything in there for us. So far we've been seeing them in paper 3, right? So far. All right.
This is don't put a lot of them questions on the paper.
I noticed that. Remember that the exam is supposed to be easy. They're not, oh, this is how we actually find one in paper 2. Look at that. So be careful. If you're expecting it only to come in paper 3, you're wrong. They could slip it in paper 2 too. And if they put it in paper 2, more than likely they ain't put it in paper 3 for the same thing. So if circle theorem came in paper 2 of that year, it ain't coming in paper 3. All right. Yep. As I predicted.
That's the homework.
No, I don't homework. See, that's the homework. Be funny, eh? But this will be our last circle theorem question, and then I'll give you one for homework. So let's quickly do this one. But one thing to note is that when they come, they usually don't exceed more than 6 points. So if you, I hate to say it like this, but if you do not understand and then you're comfortable with losing 6 points, well, you don't have to learn circle theorem. But if you're trying to maximize on every point that you could get, then learn circle theorem. And it's worth it. I mean, it's not hard. It should be. And the one thing I like with circle theorem, you know, it's not much calculation, so it's more like identifying the theorem.
This is between this and Bgcse, right?
Circle theorem?
Yes, sir.
No, definitely not. They wouldn't put that.
You gotta be kidding me.
No, circle theorem is not in Bgcse. But what I'd say is that it's good geometry practice because, like I say, it helps you to identify stuff. So because your eye is trained with these circle theorem problems, then when you're faced with the more easier ones, which is not a circle and just the basic ones, it'll be easier for you to see. Like for example, when we had to share these two triangles, share the angle that could come on a Bgcse question, but it wouldn't be with the circle. You see what I'm saying? And so you knowing how to do that is helpful. And like angles on a straight line, like how we did it here, it could come, but not with a circle. And so you still have to know that you could still use that rule. So even though they don't put it within a circle, the principles are still there. That's good. All right. So knowing circle theorem helps to train your eye to see, those things that other people wouldn't see. So it's good. All right. So let's quickly do this. CAD. So we're looking at CAD. We're looking at this angle here. What would that be? CAD. Well,
Yeah, they're 52.
52. Why you say 52?
I don't want to think about it.
It cannot be 52. No, it's not 52. I wouldn't say it's 52. Well, what we do know off the bat that this is the origin, so this angle right here have to be 90 degrees. We do know that. If this is 52 and this is 90, right? Then angles in a triangle tells us that this A is going to be equal to what? 180
minus 90 plus 52.
90 plus 52, yeah. So you see that same rule, Miss Cooper? That's a rule.
Yes, sir.
That's a Bgcse rule. You'll have to know that, but like knowing that angles in a triangle add up to 180 degrees. That's what y'all have to know. And knowing how to find that missing angle. So that's that. So what do we have? 180 minus what? 90 plus 50?
So that's because the origin and the tangent touch.
What? You mean that why this is 90?
Yeah.
No, it's 90 because of the first rule. The first rule tells us, because of this rule right here. This rule tells us that if we have a diameter, we construct a circle, this angle would always be 90 degrees.
Okay, I'm familiar with that.
Yeah, that was from Monday. You know the holiday? Yeah. Yeah. During the holiday we learned that.
Yeah, we know that. Yeah.
Yeah. Yeah.
With a throw on us.
All right, 90 plus 52. I don't understand. Let me tell you
That's
something.
okay. That's okay.
When I was a student, I used to can't wait till Easter break. You know why?
To do self-studying.
Of course. I couldn't wait. I couldn't wait till Easter break just to study. And during school, I used to duck school, take some time off from school, and just study. And
Why though?
because my teacher would be like, Isaac, you was in the school yesterday, da da da. I say, Miss, if you only knew, if you only know. I had because then what they do, right, especially for certain classes, they would throw all the work on you, all the notes that they know they're gonna put in the exam, like 2 weeks before the exam or a week before the exam. So, like, if you want to do well, like I wanted to do well, or if you want take a couple days off, you know, not. And so, when people talk about holidays, I didn't have no holiday during school. Holiday just means more time to do extra things. And so when people say, "Oh, you on Easter break," how you could be a student and you on the beach on a holiday? How?
I'll just say that's normal people.
No,
Because we can't miss it.
never. The beach never saw me when I was in high school. Beach. My goodness. How you get on the beach? You gonna stop you up to study? Beach.
Wow.
My goodness. 38 degrees. All right. And then people wonder, oh, Mr. Petit, how you get valedictorian? Because I was studying when they was playing. That's how.
I get that too.
You know what I mean? 38. Very good. Now, CAB. CAB. So CAB. So that means we're looking at this angle right now, right? How would we get that? Oh, that's easy. You should be able to see that. Which theorem are you using?
Wait, I?
Alternate.
Alternate one. Very good.
Oh.
52.
That's 52. Very good. See, now your eyes can see it. Very good. 52 degrees. So chord, angle, interior angle. So it's 52. Good. Oh wow, it's 8:02. I'm surprised no one said, Mr. Petit, it's 8:02.
I mean, Nancy's do that.
And see, that sound like she tired today. So I ain't bothered. Alright, CBA. So we're looking at B. Alright. What should that be? B angle B. I wonder if y'all could see it. Anyone could see it?
What's it, please?
Uh-huh.
Wait, never mind.
Is A and C equal?
They cannot be equal.
No?
Mm-mm.
Okay.
A and B is equal, so it's 52 because of the type of yeah.
Wow, I haven't heard from you all night.
Is it 38?
How you get 38?
The same opposite thingy.
What's it,
52?
The interior, no, that's not. Oh, no, it's not 52. Think about it. Like, look, use the idea of angles in a triangle.
So we doing the 180 minus
Minus what?
52?
Plus.
Minus 52.
52 plus what angle we missing?
90?
Where you got this angle right there, that's have to be 90. Alright, why it have to be 90? Because,
Alright, looking at that too.
yeah, it have to be 90. Because if this is 90, this must be 90. Because they should be 180. Because the angle's on a straight line.
I don't know why with that little, what you
But I
call
thought
that?
you
That
said
curve?
when the line cut through it, it's 90.
When the line cut through it is 90. But the line have to be a radius though. You're saying the radius?
This thing is so complicated for me. I quit.
Sick. Oh wow. Nancy, you're a quitter? You can't be a quitter.
No, she can't be because I remember when I say I was a quitter and she say, "Oh, not me, not me.
Exactly.
I'm a conqueror. I'm a this. I'm a that. I'm a businesswoman."
My goodness. Oh wow. Man, I love this class. Oh my, Nancy, you're a quitter?
I ain't.
And I finally joined the party.
Miss Petit.
I did not quit. I just threw my white flag in the air. I didn't quit though. And yes, I am. I'm still a businesswoman. I do not quit. I never quit.
Yeah, but you just did, like.
I raised my white flag. That could be I rested. You could never know my white flag.
No.
That's a strategic retreat.
Oh my.
My white flag could mean many things.
Okay. Including.
Miss Petit, I had 38 for the second one and 52 for the third one.
Okay, so this is gonna be. And Miss Cooper, she wouldn't let us go. Not even a laugh, Miss Cooper. Like laugh means don't calculate the questions while we're doing it, while we're laughing. That's
Oh, okay. Sounds like a personal problem to me.
oh wow.
I agree with whatever she say, even if it's wrong.
Even if it... Alright, 180 minus 9 plus 52. Be equal to 180.
Kind of the same until you get for the first one.
That's true. 38.
I said 38, you say no?
You said 38, but your logic was wrong.
You just ask how.
I still give you the right answer.
I said how though?
I don't know, I guessed that. I don't know. I just figured it would be 38. I would have put 38 in me.
The logic wouldn't work because you're saying because of alternate angle theorem.
Someone think Tetris. I agree.
The problem with the alternate angle theorem is that it works within the circle. So this angle here, B, is not inside the circle, so we can't use that alternate angle theorem for that. See what I'm saying? And plus, this 38 is not even with respect to any tangent. Like, if it was this, then I could have seen a connection, but this 38 is inside a whole triangle with no connection to the tangent at all. In terms of it being an angle formed whose edge is a chord in the circle. No. So 38 wouldn't be right because of that angle segment theorem. It would be right because this is 90, this is 52, and they're supposed to be equal to 180, so you have to subtract 90 plus 52 to get the 38. That's the logic, okay? Alright, so I want to give you all the answers to the homework from yesterday, and then I want to...
Yesterday?
Yeah, we had homework yesterday. You know the homework you didn't do? That one.
Oh, I remember the homework. Sure.
Sure thing.
The real homework we had.
We had homework yesterday. That was to Nancy, tell her the homework.
It had something to do with angles. I don't remember. I don't remember. I did it, I just don't remember what it was.
It was... I'm trying to open the file, and the file playing cute. Alright. Should open now. Okay, let's go. So this would be the answers to I think I said I assigned A through F. So these would be the answers. If you need to screenshot them, we could do that. A through F. Okay, so now for today, the homework that I give you, it will be from a Bgcse paper. I'm gonna take it from, let's say, from 2013.
What the homework was yesterday?
It was to do A through F.
A through what?
A through F. A through F.
I ain't got the homework.
Yeah. Probably wasn't paying attention.
No, I really confused.
Anyway, that was yesterday. Don't worry about it. You're dead. Alright, do this one from. Ooh, this is nice. This is homework for us. We're gonna discuss it tomorrow. I like this one. Homework. So that's homework for tomorrow. Alright.
Do you even need the like heading in these type of questions?
Heading? What you mean? Oh, the headings are important because remember what you might think is not it. So by them telling you, hey, this is the tangent, by them telling you this is the origin, by them telling you those things, oh, this is the diameter, it helps with reassuring you that hey, what you think it is by observation is actually what it is. All right, so yeah, that sometimes they're useful and sometimes sometimes without them you can decipher. All right. Okay, so let's move forward. On the language now. Kennedy, you almighty quiet today. What happened? How did that day? And if Kennedy even paying attention? Kennedy probably on the third series on Netflix, episode 49. All right.
Season 3.
Season 3. Right. Okay, good. So we're talking about technological freedom. Very good essay. If you haven't read it, you should read it. We read it on Monday, the holiday. Everyone talks the holiday.
Oh my gosh.
I just said holiday sis. Who the cap let it wear it. But it was a good essay, we can't read it again. We have to continue. But we was answering question that comes right after. Saying based on the information presented in the passage, explain the conclusions that can be drawn about the distinct ways in which people's lifestyles were different and or even limited before our society became a highly technological one. Was a short way of saying
This is the tape.
technological. Was a short way of saying highly technological.
Modern.
Short way. With like six letters.
Technical.
6 letters.
Good morning.
High tech. All right, so you had a question, Cooper?
You could give me a summary of that story?
If I give you a summary of that story? No, sure, no problem. I have no problem doing that. So basically what the story is about, it was about a girl who was supposed to be in class on Monday.
Come on, bro.
I decided
The
to.
whole synopsis was like the difference, like the advantages and disadvantages of using
Kennedy,
technology.
whose side are you
Uh,
on?
Thank you, Kennedy, because Mr. Material Gurney, I don't know.
come on,
Whose side are you
I
on?
did it. I neutral.
Kennedy say she neutral. You know they say with the neutral guy.
That sound more chaotic neutral though.
But go ahead and Kennedy, give us a summary.
It was like on the first paragraph, it's like a compare contrast of how people use communication and all that stuff then and how they use it now. But during the essay, they was just talking about the advantages and disadvantages of technology. So
The advantages and
Thank you.
disadvantages. Um, really, it was basically a delineation of of the ways technology could be used, right? They talk about, or it has been used in our modern world. So it talks about how technology really facilitates some of the very important things that we need. For example, education. They talk about how persons can now get their bachelor's and PhD and MA from, you know, accredited universities by in the comfort of their homes and not having to actually go abroad and pay for boarding and stuff. It talks about how technology helps to facilitate interaction, social interactions, you know, um, you know, like um, for example, with with the um with the with the ability to have phones and calls and text messages instantly. You're able to it basically facilitates communication and talking among among other people. It also talks about how um technology helps with marriage, finding a mate. Um, and you could be able to find a mate on who is in Bermuda, who is in Zimbabwe, wherever, and not be limited to the local selection by just going on certain sites, which I don't recommend, but that's what they're saying. Um, it also talks about how people can, use the internet or technology for fitness, by, watching television programs that deals with fitness by using a Wii um, you know, how it helps us to, um, what else? Helps us to explore other religion. Instead of going to the church, you can watch it on television or, you know, go in their live meeting. I know Monteba is doing live meetings and persons even from Africa is tuning into their live meetings. I was listening on the radio and they was talking about their successes with that. Um, and so this is basically talking about how technology can be good, and then at the end, talk about ways technologies can be bad in that, it facilitates identity theft. Persons could go on the wrong sites and watch the wrong things and stuff like that. So it's basically this essay in a nutshell. And so the
Thank you.
question, no problem. So the question states that based on the passage, explain um, how we can draw conclusions about what happened in the past versus what happens now. And so and as they say, use no more than 200 words, it's 12 points. And in our discussion together with this, we basically was talking about the different ways we started, but we didn't finish because, of course, there's a lot of things to tease out. We talked about the communication, um, how sorry, how we communicated before by typewriting and dropping off the post office, but now we use phones and stuff like that. Talk about for socializing, how we had to physically go to events, but now you don't have to do that. Education, we talked about how we had to physically go to school, physically go into a library, but now we can have access to some of the world's greatest libraries without leaving. Um, our bedrooms. And then entertainment, we talked about how in back in those days, you know, you had the crate in you had the crate tied to the fence, and play basketball like that. And how, you know, basically the main um, methods of entertainment was the cinema or theatrical performances, but now things are different. Children don't really play outside no more. You know, Fortnite is the name of the game, um, and persons don't have really a outdoor experience, and some of the practical things they supposed to do, they don't know how to do. As you know, today we were supposed to do like a not supposed to. I wanted the students to do something like I wanted them to help me to make a chart, and I asked one of the students to cut something for me, and the student said they don't know how to cut, right? I was like, you don't know how to cut? It's like, yeah, I don't know how to cut, and you know, because their hand shakes and stuff like that. And so, you know, I think that if we had more, you know, of that old times construction, you know, where you know you do your project and you carry your project to school and you know you do your own stuff and you make the hour thing and whatever. You know, I think that those things would be more developed as opposed to now with all technology and stuff like that. You know, things are the more hands-on things are being put away, and so we have a lot of people who can't do the practical things that they supposed to, and so that we're losing on that end. But we're also gaining on the another end because you know before our time we had you know adults. I mean, like you can tell now adults, some adults in you know in certain offices they don't know how to use the computer and stuff like that. But now these children nowadays, you know, they know how to use the tablet by the time they're before they even 4 years old. And so by the time they are adults, you know, the next generation of Bahamians taking over would be really on the technological end. And so that's a plus. Um, you know, so those persons who are replacing the persons who are there now will definitely be computer savvy. But I would say more phone savvy than computer savvy because there's a big difference. Um, because I know students who they could use their phone, but to do a laptop, to do a PowerPoint presentation, they can't do. And so I was like, what was, you know? So, you know, so forgive me with the correlation between the phone and the computer, because there could be a difference. But I think that at least the access to knowing how to use a phone early and knowing how to use a tablet early, the crossover wouldn't be such of a steep hill to climb. So I think that's a good thing.
Mr. Petit,
Yes, ma'am.
the first three, I could take a screenshot of them, please.
Yeah, you could do that for sure. Yeah. So
Oh,
we talked about the essay, and we're gonna continue
thank you.
to look in the part in the essay for more. So the next part that we should have talked about was um privacy. Excuse me, sorry, privacy of lives. So so I don't know if any of y'all in doing this for homework when I said to do it for homework noted this one, but this is a very interesting one. It could easily pass you by if you're not paying attention. But it says that beforehand we knew relatively little about the intimate details of the lives of others. And close to nothing. And close to others. And close to nothing about the private lives of public figures. Right? Um, but now, right? Now, what's happening? You know, what's the difference now?
They got your YouTube.
Yeah, we go ahead.
They like post their
Mm-hmm.
what happened every day on the status and all them stuff.
You can imagine, like, there was no such thing as status a few years ago. There's no such thing as, like the lives of and the lives of like, if I promise you, if it was like 5 years ago or 10 years ago, and Will Smith slapped Chris Rock on Oscar, we wouldn't know about it. We wouldn't know about it.
But
Reason
good
why we
thing
wouldn't know. Reason why we wouldn't know this because if it was playing on TV, they probably would have cut it, right? And so it wouldn't have been a big embarrassment.
Yeah, and there would have been a lot of rumors.
There would have been a lot of rumors, right? But to actually see it happen, in front of you, it's like, like you can't hide that, because, everything is public now.
It's a bit deep. You know what else they can't hide?
What they can't hide.
Police brutality.
Police brutality. Yeah. Someone clapped just now. But yeah, you're right. That's true. That is also on the scene. That's true. That's very, very. I mean, granted, some still
What did
get.
he say?
Go ahead.
What did he say?
He said that sometimes students don't be paying attention in class, so sometimes they miss out the most important.
Wow.
The most important parts of the lesson, but yeah, and I was saying that that's true because once you focus and alert, you wouldn't miss anything.
That's true. Very true.
What did he say?
I tell you what the man say. All right, he was saying that one of the things that cannot be hidden nowadays is police brutality. And I mean, still to a certain extent, that that can be hidden, but not to certain things cannot be certain things can not be hidden, like you have the cameras there, and so that is on mainstream now, like and it caused us to be aware of a lot of things that happen, and unfairness and injustice and stuff like that, and so that is a new thing that's in the awakening and stuff like that. But back to the privacy of our lives, not only the privacy of public figures, but even our own personal privacy, right? Um, when someone, like, let's say for example, you were in high school and someone who got married, if you didn't keep their number, or if you didn't keep, or if you didn't keep, if you didn't know where they live, or if they didn't even know invitation, you wouldn't know that they are married. But now, I knew someone. He was I used to work for his mother's food vegan restaurant, not restaurant but vegan eatery, and um I saw his wedding picture on Facebook. Now, if there was no such thing as Facebook and stuff like that, like how was I gonna know that detail about his life? Right? I wasn't gonna know, and so the details of your life are open for everyone to see. I mean, granted, provided that you post it. And it's so detailed that I could even know what someone who I graduated with, what they're eating like tomorrow. You know what I mean? That's how detailed it is. You know what I mean? Do you find that disturbing, alarming, good, bad? What do you think? I think it's good.
I find that scary. That's why I don't have a Facebook account. I don't have an Instagram account. I don't have none of those things because I think
Okay.
I don't like it. It's not my thing.
Okay. It's too public, right?
I can agree that it
I
is
agree.
exploitable. However, I think it is also very informal. You know,
Informal.
that's yeah, like it has useful side too to it.
And you use the word informal to describe that? No,
Yeah, because it's just you just gathering information about someone.
that's not. Nah, no man, don't use that word informal. Informal means something that is not formal. That is to say, something that is casual. You know what I mean? So pick a better word.
I was thinking about it casually, so that's what came to mind. Yeah, like although you see they get married, and like, oh my god, I missed that. It's like, oh, that's nice, you get married.
Yeah, yes, that's true. I mean, that's all it is. I mean, to be honest, but still though, like, I can understand what Nancy's saying. I understand what you're saying. Like, it could also be one-dimensional too. It really could be one-dimensional because, you see a person and they take a picture of themselves and their significant other, and the only picture that you see of them is when they're smiling and happy, right? So you look at that and say, wow, you must have a decent relationship, right? And then you don't know the inside story, right? You don't know that that all they did was they took that picture and then, they only for that moment, and then they gone back into their rough, no talking type thing. It was only for the picture. And so it could be one-dimensional, and it could be, false. I saw something like that, whereby, persons do stuff. I saw something where the person, took a picture of their healthy plate, and then and then the real background scenery, they push that healthy plate on the side and start eating the real thing that they were supposed to eat.
So you don't do that, like you go secretly food.
Maybe, of course not, man. I ain't working.
When are you do that?
I know these things people make fake websites and stuff like that. Like,
yeah.
That's why I came off, because the drama was too much, man. I was like, yeah, I gotta. It ain't for me, man.
Can't handle drama. All right.
No, it wasn't for me at that point.
All right, that's no problem. I think it's actually it's beneficial because sometimes you can get distracted. But I do think there's pros and cons, as with everything, right? That's what life is. I could be honest with you. Life is, and this is my personal philosophy, life is joys, a lot of joys, but sorrows as well. That's how it is. Something could be so good at the same time so bad. You know what I mean? Crazy.
I get you. I got you.
But yeah. Anyway, so
do you know you can't have that conversation? Yeah.
Yeah, I know, right? I can't have that conversation. That's like post 21 conversation. But anyway, I think it's good. The quicker you understand that, the better you.
Use paragraph words for that and for privacy of life.
Say it again.
Which paragraph would you use for that?
All right, so privacy of our lives. When it's talking about how we know what the public figures are doing. So that would be we speak of technology increase. There are hundreds of dating sites. No. More comfort. No. Egypt studying.
Cell phone work for that again. They like the cell phone part.
Oh, I do this wrong.
No. Yeah, very good. This would be paragraph. This is starting from the one that started, of course. So
media.
Yeah, of course, the media. So it talks about how consequently we find the most intimate details of our favorite sport heroes, right? And discover the transgressions of our politicians before they can take steps to conceal their indiscretions from the preying public. So I think this is very good. And so before, the people could get away with,
The paragraph 3?
No, that's not paragraph 3. Of course, it's paragraph 1, 2, 3, 4.
4.
Paragraph before. So I think this is really reality television shows flourish, and the mundane and often downright obscene details of people's lives have now become what highly profitable entertainment. And so yeah, man.
Real Housewives of Atlanta.
Oh yeah,
The Kardashians.
And that could fall under news as well.
news. Yeah,
Yeah.
yeah, news. Very good. I like that idea.
Um, you could have news as one, and then you could have in the modern day how they read the paper and gossiped about stuff.
Oh, you mean in terms of in the past?
Yeah, you would just hear rumors and gossips based off
Yeah,
of
you
like
wouldn't have. Yeah, you wouldn't
letters.
have. That's true. You wouldn't have like concrete, like a video or you mean like, you know,
No, yeah.
yeah.
Wouldn't it be like you get a letter from a long distant friend from a different country, then you would spread the news with the neighbors and
Mm-hmm,
stuff like that,
mm-hmm, mm-hmm,
and then it becomes rumors? Okay.
mm-hmm, mm-hmm. But there wouldn't be like a audible or visual instance of the thing, you know. The next thing is shopping. So, oh no no no! Before we get to that, political awareness. So this is another one. Political awareness. We talked about this in brief, in passing, really. So this one. So with this one, we talked about so what's the difference between now and then is that before we relied, we had to rely on the press to report on the doings. This is exactly what Nancy was saying. Also, let me put the paragraph here. Paragraph. Paragraph 4. Oh, before I even get to that, right? We talk about the safety. Thank you. We talked about the safety of or the safety or security of the safety or security of personal information. So back then there was more safety and security of your own personal information. Would you agree?
Yeah.
It's hard to agree.
I agree.
It's hard to agree for me
What?
because of what Nancy say actually contradicts herself.
No. Okay, so in terms of what we talking about, like the technologies that we have today heighten or facilitate identity theft. All right, like it happened to me. I didn't realize how much it was, but um I realized that I that there that's that when I went to my bank statement, I realized that there was a purchase that was made that I promise you, I don't even know the website. I didn't even know that website exists, right? So I say to myself, I say, someone have my card information. That's the only thing I could think of, right? And then my mind goes back um, to when I allowed someone to change my tire, and I had my card on inside my car. And when I came inside the car, I said, well, wow, Dre, why did I leave this in there? I didn't even realize I leave it there. And so just like that, my information was gone, and someone already gone and do a whole several purchases, right? And so I had to get changed. And so who's that laughing?
Nancy, your best friend.
Nancy, man, what happened? Why are you laughing at me?
That for being careless, man, Mr. Petit, man.
What's sending me, careful.
That's just carelessness.
Man, it's my car.
Yeah.
It's my
Just
car.
get sweet.
It's my car. Why have to?
So like, you don't have it in the wallet or nothing?
Yeah.
Why have to hide?
Dude.
No, that's like a straight up swing.
Why had to hide? Why have to hide stuff in my own car from myself? Like, what? Don't worry. You have a chance to be an adult, and you will understand what I mean. Like, you don't like certain things. You don't really like. You know.
Yeah, because they have a saying, it takes one to know one, so you wouldn't
Yeah.
really be thinking like that.
No, you wouldn't be thinking like that. You know what I mean? Like, so, give me one moment. 1 second. All right, so yeah, I mean, call it carelessness, right? But how many times you supposed to be going to school and you can't find your shoes, right? Or you can't find your necktie? Like, I mean, someone could call it carelessness.
You exposing me?
Like, I mean, it's life. You know what I mean? Like,
No, I never had that issue.
you never had that issue.
No.
All right. I can give
I
you,
always
I can give you a good issue, right? But I can't, I want, like, no one can make the case that there wasn't something in their life that they did where they realized that they should have thought about it before they do it, right? Or it catch them on a, you know, on a, they catch them at that was a low blow, like they catch them off guard, right? And sometimes if you thought about it, you could have prevented it, of course, but I mean, granted, you can't prevent everything. I mean, it was this,
That happened to me today.
It shows that you just trust people so easily. Like,
no, I mean, it has nothing to do with trust. It has nothing to do with trust. First of all, I didn't remember as the first, because only when I did I remember that it was on the dashboard.
my own fresh charges against them.
I didn't even remember.
So they take a picture of it.
Mr. BT, why you press charges?
I mean, who has time to do all that, man? I just changed.
I bet you he's gonna get $30 on your credit card.
I wish it was $30.
Take a picture of it.
I wish it was $30. But yeah, I guess they took a picture of it or whatever.
He buying new best sneakers.
You still talk to him?
And so
you went back to the person.
I know Mr. BT friends with him now.
I just leave it. But yeah, that's what we're talking about when you talk about personal information and security. It's easy to get access to your money now. I mean, if I had that money underneath my mattress, like, no one is gonna sneak that and buy whole, I mean, I tell you, I never did this site in my life. I say what the site is.
So what they buy?
I can't remember. I think it was a jersey or outfit or something.
A nice sneakers, right? It had to be some clean sneakers when you go through a life.
I can't remember what it was.
Mr. BT, I ain't gonna lie. But when I'm tired of changing people, they scam, man. They try to do that. I mean, they try and rob my mommy and my auntie before.
Yeah.
I'm trying to rip them off.
Yeah, you gotta be careful. And so yeah, that's what we're talking about. The privacy of your information is not as secure as it was before, because it's easy to get into your intimate, information. Like, all I need to know is one password, like, and I get access to all your financial, records. All I need to know is one password, and I get access to all your emails. You can imagine what that is? All I need to know is one password, and I get access to your whole library of friends, right? That's scary too.
But don't forget this, you still have to do the verification thing too. So you
but that verification thing, if, like, for example, my laptop, right? I always think about it, like, on my phone, like certain things you already have like have it saved. So I wanna have to sign into my computer all the time with my Gmail. It's already there, already open. You know what I mean? And so if you have my laptop, you got to go on for a ride, because those things are already up and they open, and so you have access. And so it's easy, very easy.
That reminds me of a scam they used to do at like popular locations like Starbucks and thing, but it's used. And then they put down a USB drive, and you'll be curious, what on this USB drive? And they plug it in, and then they install it.
That's why I do not use public Wi-Fi, like, as a general rule. If I can help it, I tend to use my own. You know what I mean? Because if you use public Wi-Fi on your personal computer,
They have so much advantages. I'm telling you that.
They could
They could dog you, threatening you so much things with your IP and all that.
yeah.
We only have a little time left, not to
Yeah.
catch a conversation, but you know.
You're right. Okay.
Hey, Mr. BT.
Go ahead.
One question. Do you like receive a message from some random person saying you won this amount of money?
Not one, but they
I
like.
just come to me on WhatsApp.
Wait, I'd be like, why you trying to scam me? When I ask the person, I'm not. One of them say F me and block me, and one of them DM me again, right? And so they say hi. I say yeah, this is a scammer. And I copy and paste original scammer message from my DMs and send it to them because that's what they was going to tell me.
Oh. Wow.
I not tell them, hey, I can win something. I born and win up.
It's so it's funny, right? Because they say you win something, right? But I don't play games or nothing. So like,
exactly,
I win
$500 million. Like, bro, what?
You had to rely on the press, and anyway. Let me.
Elon Musk.
You had to rely on the press to report on the doings.
The press means newspaper.
Yeah. But the press not only means newspaper, but the public press, news.
News in general.
On the political leaders. Yeah, news in general. On the political leaders, or make rare trips to venues where governmental representatives convene to make decisions. Now, that's a good observation that is there. Like, currently we can actually see Parliament though. We know exactly what's happening when Hubert Minutes talk, or when Minister Brave Davis talk. We know exactly what's happening. We know what the opposition said. We know what the with the governing side said. We don't have to wait until the news come and report what they hear in Parliament. We could see what's actually happening in Parliament. And so that is a difference. And we know what's happening. We know what's happening in the lives of the politicians, and even before the news actually broadcasted. Like, we know we have them on on Facebook, we have them on Instagram, and this is so powerful that this is one of the ways you know how people they win elections, by making a proper use of Twitter. Twitter presence is important. All the presidents, Obama, Trump, all of them, they use Twitter wisely to speak their voice, and to get awareness of who they are, and what they stand for. Donald Trump was big on Twitter, and so much he even got banned. You know what I mean? Persons understanding that, hey, wow, these social platforms could be big ways where they could generate money for their campaigns, where they could speak their voice, where they could give basically get free advertisement, because so much people there's a speaker message on a television. You don't know how much money you have to pay, but you could do it on Twitter for free. You know what I mean? And people listen. You know what I mean? And so, yeah, that's a big thing. The social networks really changing the dynamics of politicians, of politics. And it's almost that the better you are with social media, the better your campaign will be, and the likelihood of you winning is greater. And so, that's also something. All right, so we have shopping. So you know, um, before, what did we do?
We used to walk into the
Walk
store,
to the super.
We walk.
take the bus, board the bus,
Yep,
and
you
we
know,
go shopping.
public transportation to the mall. Transportation to the mall.
Paragraph 4 would be for political awareness, right?
Say it again. Yeah, four. Four would be the same.
Okay.
Also, before we used to shop with our own money, but then
Yeah, you walk with your cash. It wasn't it pennies back then?
Yeah, yeah, that pennies. Yeah,
Yo, it wasn't a dollar. It was pennies.
How much things you gonna get? All you need to do.
No. That ain't what I meant. I meant
credit card.
Okay, you get it.
Huh?
What
did you say?
I say you get what I was alluding to.
Yeah, you mean credit cards, right?
Yeah, before we used to shop like with our own hard-earned money.
Yes.
But why do that when people leave their card out and open and you can shop with theirs?
My goodness.
Yeah, and that's the petiteness that comes in the class one.
Yeah, why do that when Mr. Petite is keep his, stuff on the dashboard? That's what you need to do, right? My goodness.
We need to go back to the times where we just use pennies, because I think it'll be easier.
A lot of counting.
No, I mean as in like we keep our dollars because now this is going cashless, and it's very difficult.
It's difficult going cashless.
Really?
It is difficult because chances are theft. I could lose the card.
Oh, you mean like that?
My money gone.
Oh yeah.
I could get swing.
I mean, like I said, one thing, we have to understand with everything, right? Is that everything has its disadvantages.
I understand, but pennies don't have no disadvantages at this point.
It does have disadvantages, right?
Yeah, I agree, Mr. T. It does.
It does have
What is wrong with paying in cash and carrying cash with you?
You could get robbed.
Well, that was happening from that Kingdom Come.
The cost of production.
Mr. B.
Yes, sir.
You know, if you pay a credit card, you spend them all money, right?
Yeah.
Thank you.
Yeah, I mean, but it depends. It depends on. You say credit card, debit card is different. Debit is you pay what you have on.
I might buy me a debit card. Yeah. I just mean a debit card. I mean, if you pay with a Visa debit card, you spend more money.
Oh.
The taxes and things.
And then there's come with convenience fee. And then there's be like the convenience fee. Yeah, convenience fee, tax.
Yeah, I think it's $5 every time you swipe.
Convenience fee, like I say.
I know true. No $5 every time you swipe because I used to.
Yeah, RBC debit card $5 every time
they charge you.
Yeah, social bank do the same thing when you want money.
Sorry, what do you think that is?
Okay. We need to go back to cash.
When I see people using their money to buy food with card, it's like, wow, these people, wow.
Sometimes it's be that they on credit card, so they don't have the real money, so they ain't getting paid until the end of the month, so they gotta stock up and use the credit.
Yeah, that's reasonable.
So when you see they flex,
and then be broke by end of the month when the bank swipe your card. Oh no!
Again, and the cycle continues.
And you go back into debt and today. No, I can keep my money in my mattress. At least
also,
I know
Ms.
what.
Petit, did you know if you take your debit card in the States and you you swipe, you check out and you put debit card, they charge you $20 to swipe. But if you put credit card, it ain't no cost to you.
Yeah, because they pick on credit over there. I trying to figure out where we could find information about that, the shopping. In addition, of course.
You gotta go further down.
Yeah. Well, I just saw it. This is religion. This is proliferation of theft. No, that's that. Shopping. Oh, there we go. Moreover, technological advances allow us to shop from the comfort of our home, making immediate deals and purchases to our pockets or credit cards content. Without venturing outdoors, we're able to shop across the street, downtown, or the world. I mean, this is amazing, right? One of the things I love about these things is that I can be honest, is that we are able to get access to content and services that we would not been able to get access to, especially services, because I remember and this helped me a lot when I was in undergrad. Like no one who I knew personally could have tutored me, right? Because they just didn't know, they just didn't know the stuff I was doing, and so I had to go online to find tutors, and the people who I found online, I mean, they were so smart. Like, oh my goodness, like they would work for so little. That's the thing. And it was like brainies, right? And so that helps. So being able to, and how can I pay them? You pay them through online. So and so they helped me with my work, and they was very smart. And so like I feel like that was a good part, because the internet made services that couldn't, and maybe be able to interact with people who I couldn't otherwise interact with, and they could provide me their service, and I could benefit from their help because of this technology. And so it's very good. So this is virtually, so this paragraph, what this is if this is paragraph 4, 5, paragraph 6, paragraph 6. So I think that there's pros and cons. You know what I mean? Sometimes NASA do not have some of the things that you want and need, and you have to shop online for it. And so it could be a benefit. You know, and that's so good, because you can imagine, like, if you have a car and your car is not a Honda, or uh, or a March. Let's say you have a car like mine's like an Impala, right? If you have something like that, like you cannot. The parts, you find the parts over here is so rare. I mean, oh my goodness. And so you have to, if either you're gonna wait for the shop to order it, and if they said well, they're like buck, or you have to order it yourself. And so imagine if you know imagine if you didn't have that component to be able to order it yourself, then that would have been a sad thing. So I think that that ability to shop online is good. That's the good side. Of course there are bad sides to it.
That's a bit deep.
Yes, sir.
I used to shop online back in the day too,
Okay.
Back in the days.
Yeah.
Yeah.
Bro, are you like 17 or 16?
Yeah, there's a shop online back then too.
My grandma still walking down the road to get her clothes made up to this point. No, so
they used to shop online then, because they used to go on people's clothes line and get their clothes. So they shopping online.
They used to look at the magazines and then go to the dressmaker and request that the dress be made.
That's nice. All right, so fitness and healthcare. We exercise by getting what we previously we exercised by actually getting outdoors, right? Or going to the gym for a workout. But now
This is the only thing I think that didn't have much change because we still do that a lot.
We still do it a lot, right? But with the advantage, with the opportunity of technology, you could actually do it at home and still get a really good workout, I guess. Especially when they talk about the Wii. Anyone remember the Wii? People still have that? The Wii.
I used to, I lost it.
I never heard of the Wii.
You never heard of the Wii? Like Wii.
What that is?
Mario Kart and thing? Wow.
Yeah, Wii game like this.
Oh, that.
The Wii. Anyone ever had a Wii? I used to want a Wii so bad.
No, I had the one which you open up, like the flip. What it called? The flip
Nintendo.
Nintendo. Yes, I had that.
I have a Nintendo on a PS4. That's what I got.
Yeah, I had the Nintendo crazy thing. I didn't have that.
So basically, you could be actually actively involved in a game. You know what I mean?
What one do you skip?
With the Wii, it'll be nice. Like it's a good workout. You know what I mean? You could do bowling. You could do and so that's.
Wait, I gotta get up into the action.
You have to actually get up and do the action.
Yeah.
Yeah, that would be nice.
But with the things attached to your hand, the controller things.
So it was a good way to get
it's the BT. You see the Wii U was talking about, right? When I had that when I was in grade. Hold on, listen. I was in grade 2 when I got it because I got a 3 point, and the third, like when I got it, the third day it was messed up and I couldn't play no games, right? Because my brother put a lizard inside the box, the box thingy had holes in it. The Wii had holes in it. And ever since that, I got in it.
At least for the stuff you get. Wow.
It's 901.
3 points.
My time is wrong, but my time is not right. It is it's actually 8:01. Remember time changed, right? Remember that?
It changed back, so
back again.
It what? It what?
1 hour ahead.
Change back again.
Remember, you forget you forget that
we can give you time to make up a lie.
Yeah, let me do the last one. Romantic relationships.
Oh
boy, God,
I had to do that. I promise.
See, that's why I need to stop getting the numbers of
what?
Of my students. So we used traditional ways.
Back then we used to go up to the ladies and ask them out formally, but we still need to do.
Nah, people don't do that these days.
So people is tapped.
Yeah,
equality.
You see, it's easier to act on social media than in reality because people is be right there watching you and can't mind their own business.
No,
and
that's what makes you a real man.
And
doing it.
Imagine they say no. What are you gonna do, Mr. Petite? They say no.
Then
cover your face. Just cover your face and walk off.
You learn that rejection is a part of life.
It's the BT,
and you will develop way more in terms of character.
To develop, develop. You can get anxiety from that. We're talking about
anxiety in life. You understand that? Or you think life is just about being happy and go lucky and breaking up in 3 days? Does you think life?
Mr. BT, you ever had a girl in your school you like?
You mean my books? Yeah.
He had one.
Mr. BT, you like every girl you had to look at, he said, "Ooh, she's fine." Ooh.
Anyway. Like a so bad you.
Mr. BT had his feeling.
We use traditional ways of courtship and so had limited options concerning the choice of partner. That was back in the day. But now, with the invention of, these sites, we can have partners overseas, have long distance relationships, and they could come to the Bahamas, we could go to Dubai.
Don't do that nowadays.
Have to buy money, eh?
basic divine really expensive, you know. It ain't expensive.
Oh boy, there goes.
It isn't expensive. It isn't.
Anyway,
Way cheaper than that. Way cheaper than Nassau.
all right, so we could bring it to a close for the night. We have three more things. Three more things, I think. Worship practices, media responsibility, and exploitation of children. What I want you to do for Monday is I want you to do um number 4. Do number 4 for me, please. Um, yeah, do number 4. You are a keynote speaker addressing a group of 12th graders at graduation. Write a speech in which you will seek to prepare them for the world they will enter after graduation. Remind them of the different ways in which they are free and explaining the responsibilities that come with each.
How do I get relevant to the whole essay?
Now, they say in your response, you're expected to present ideas on information from both passages and then include one or two ideas if you want. Because I love this, man. This is this is amazing. I don't want to spoil it for you, right? I really don't. But what they basically trying to say is that remember the first passage talked about the freedom of slavery, but it had an ironic twist to it that with freedom comes responsibility. And so they want you to talk about that idea, and then they also want you to talk about the idea of technology that we live, we live in a tech savvy world. But what would you want to tell 12th graders leaving graduation about technology? Would you only want to talk to them about the benefits?
Be careful of it too.
Exactly. So that's what this should be, man. If I had this for my exam, I would have loved it.
Well, we know you.
Even I couldn't wait. And notice they don't have no word limit for this. Why? Because
They want you to go all out.
they want you to go all out. Want you to go all out.
But isn't time limited? I hate these kind of questions, man.
Time is limited, but I mean, hey, write fast. Write fast. Alright, so that brings us to the end of this study. Any questions before we go?
Mr. Badi, I got you something after class.
Concerning biology, the work I sent you, did you ever got a chance to look at it?
Yes, I did. Did you check the slide the message
already, but I was just kind of like, because I don't think about time.
No.
I trying to do this.
Okay.
Mr. Bethel.
Oui?
Good night, Mr. Petit.
Stay back for me too, please.
All right. I'll say great conversation for when everyone leave.
Yes.
I don't have to stay back, right?
No, you don't have to stay back, man. But just read the message.
Okay.
All right. So.
Good night.
Good night, everyone. Have a wonderful
night.
See you tomorrow.
Good night, juveniles.
Mr. Bethel or something. All right. So.